Here I am explaining how we can use this step up converter to transfer energy from this voltage source to this voltage source. Here in the load side we have kept a battery here, and this is considered as a source voltage. Okay, so step up operation can be used to transfer energy from one voltage source to another. Here we are transferring the energy from this voltage source to this voltage source. So when the switch is closed, the energy from this voltage source is transferred to an inductor. Okay, so that I'm showing here. So later, because its equivalent circuit, see, that is a mode 1. Mode 1 means when I close the switch, so current is flowing in this direction, so this diode is not forward biased. This load side, this is load, so this is a battery here, batteries are here. This is completely detached from the source side. The current is flowing from source through inductor through switch in this way. Mode 1 equivalent circuit is shown here. This is voltage Vs, inductor is here, switch is closed, so it is acting like a short circuit. It is closed switch, it is acting like a wire. The current is flowing in this direction, so the energy from this voltage source is completely given to inductor, so, or transferred to inductor. So there is an EMF induced here across an inductor, but during this interval this side positive and this side negative. The sign of the EMF induced here positive and here negative, actual EMF sign. Okay, so the current will rise. Okay, we will get an equation for this I1 of t. Okay, the current increases in this way, current increases from one value to I2, current increase. This is a steady state current, this is a current waveforms, current rises. So if you apply a KVL for this is Vs, the L d I1 of dt, this is a EMF induced across an inductor, is equal to 0. See here, if you write d I1 of dt by d1 of t by dt is equal to Vs by L. What is that? This is change in current with respect to time. This is slope of the current waveform is Vs by L. So here we can see that in the current waveforms, the slope of this current line is current waveform is Vs by L. Please keep that in mind. Then if I require equation for I1 of t, then I should use a Laplace transform. You just apply the Laplace transform to this equation. Vs becomes Vs by S minus L d I1 of dt becomes S into I1 of S minus I1. What is I1? I1 is an initial current. Then Vs by S plus L I1 is equal to, you keep this Ls I1 of S right side. So Vs, yes, okay. So this L you take here, yes you take to denominator, S squared, L I1 L S I1 of S. So Vs by L S squared I1 by S is equal to I1 of S. So you just rewrite this equation. Okay, so we got an equation for I1 of S. It is in S domain right now. So Vs by L is a constant 1 by s squared plus I1 into 1 by s is equal to I1 of s. We knew that 1 by s square, you apply a inverse Laplace transform, so we will get I1 of t. 1 by s squared inverse Laplace transform is t. 1 by s inverse Laplace transform is 1. So Vs by L t I1 I1 of t. This is an equation. It is describing the current equations in during mode 1. We can see here Vs by L into t plus I1. It is just like mx plus c, correct? This is c is a constant, m is a slope, here slope is Vs by L. So in this equations, Vs by L is a slope, or it is nothing but initially we have seen that what is the Vs by L? It is di1 of dt by dt. Means the sense change in current with respect to time. It is nothing but slope of the current waveforms. So slope of the current waveforms. Okay. During mode 1, inductor current I1 of t must rise. So we have seen that I1 of t must rise, correct? What is the meaning? I1 of t must rise means the slope should be positive. What is the slope? Vs by L. Vs by L should be positive. Means what? Vs by L should be more than 0. Vs by L is more, slope should be more than 0. di1 of by dt is equal to more than 0, or is nothing but Vs by L should be more than 0, or is nothing. It's therefore Vs should be more than 0. This is a one necessary condition. Next, in mode 2, we open this switch. So we are going to open this switch. What happens then? The EMF whatever is induced earlier, so now what happens? Now also EMF is induced, because the current will start reducing. Current is at somewhere here. The current will start reducing. Whenever current start reducing, the EMF is induced across an inductor. But the current is reducing, so L di1 by dt. Here di1 by dt, di2 by dt is negative, means the slope of the current is negative, means current is reducing. So the EMF whatever is induced here is opposing the current reduction. That's the reason the actual sign of the EMF induced, this side negative and this side positive. Okay. So what happens, strictly speaking, when I open this switch, this energy and this energy added up together, and it is transferring the energy to the load, because these two, when it is added, it is more than E. So this diode is forward bias. So we will find out an equation for mode 2, means we will find out a current equation I2 of t. I2 of t exists in mode 2. It is from kt to t, or you can call it as a time duration t2. So I am opening this switch. So this path is a broken path. So Vs L di2 of dt minus C. Vs minus L di2 of dt minus C is equal to 0. So Vs, so if you just apply the Laplace transform, so first apply the KVL. Vs minus VL minus E. So Vs, what is VL? L di2 of t dt minus C is equal to 0. Vs by, so you just apply Laplace transform. Vs becomes Vs by S minus L. I2 of t is S into I2 of S minus I2 minus E by S is equal to 0. So Vs by S, so minus L I2 plus L I2, so this minus and this L S I2 SS, so minus this, so it becomes L S I2 of S, then this minus C by S, okay. So Vs minus E by S, L I2, LS I2 of S, Vs minus E by, so this L you take to the left side, so that goes to denominator, Vs minus E by L then s also you take to left side, so this s goes to v yeah, there is a mistake here. This should be s squared. This should be s squared. So this should be s squared here. So this is s, right? No, when this s comes here, this should be s squared. So then again here, so vs minus c by l, to this is s squared plus l cancel, so I2 by s, I2 of s. So this is an equation for I2 of s. I2 of s is vs minus c by l into 1 by s squared plus I2 by s is equal to I2 of s. So if you apply the inverse Laplace transform for this, what happens here? So inverse Laplace transform becomes, so what happens to inverse Laplace transform? See, if you apply the inverse Laplace transform for this, vs minus c by l 1 by s squared is equal to t, then I2 by s is I2, and I2 of s becomes I2 of t, because we are changing from s mode to t mode, so s domain to t domain. So I2 of s becomes I2 of t. I2, this is a constant, so I2, 1 by s is 1 inverse Laplace transform, 1 by s squared inverse Laplace transform is t. So it is vs minus c by l. Okay. So we got an equation now, right now. So we can see here, this is the slope of the slope of the I2 of t, I mean the slope of the I2 of t. So for a stable system, I2 of t must fall, correct? Must fall. Means what? Here you can see here the steady state current waveforms, so the I2 of t must fall. Means its slope should be negative. What is the slope of I2 of t? It is, we have calculated several times. So here Vs minus E by L. It is a slope of I2 of t. So Vs minus E by L should be negative. Means what? So Vs minus E by L should be less than 0. So Vs minus E should be less than 0. So Vs should be less than E. Vs should be less than E. So condition for controllable power transfer is, that's the reason earlier we have seen first condition whatever we have derived is for mode 1, Vs should be more than 0. Vs should be more than 0. The conditions whatever we have derived is Vs should be more than 0. Later the conditions whatever derived here is Vs should be less than E. That's the reason Condition for controllable power transfer is Vs should be more than 0 and less than E. Vs should be more than 0 and less than E. Condition for controllable power transfer is Vs should be more than 0 and less than E. See, I will tell you why this is important. Means this is very important practically because it is used in a regenerative breakdown. Sometimes when you want to stop an electric vehicle, uh, uh, assume that that wheel is running, wheel is in running state, means wheel is coupled to the motor is also continue to rotate because of the wheel rotation. Wheel rotation. In such cases, the coil is rotating under a magnetic field. It is acting like a generator. So even though in that status, means in regenerative mode, so when motor is rotating because of the wheel inertia, the motor is rotating under a magnetic field, it is acting like a generator. That power we can use to charge the battery. So here we need to think that there is motor is there, and that motor is acting in acting like a generator. So that energy we are initially giving to an inductor by closing the switch there, and later we will open that, so that previous EMF, because earlier when you open that, the EMF induced here sign reversal take place, this side minus and this side plus, these two energy will be added together and it is given to battery. So if this is your electric vehicle battery, so I can charge my electric vehicle battery during regenerative breakdown. This is widely used in that applications. Thank you.